Just 4.2 light-years away, a planet orbits the closest star to our Sun, Proxima Centauri b. It sits in the habitable zone where temperatures might allow liquid water and maybe life. This isn't science fiction, it's one of our most promising hopes beyond Earth. For centuries we've asked, are we alone? Now a small rocky world near a red dwarf star keeps that question alive. If you could stand there, on alien soil under a dim red sky, would you feel wonder? Or the weight of possibility? Let's dive into the secrets of Proxima Centauri b, and what it could mean for our future. Proximity to Earth. What would it be like to live on another planet? Well, we might not need to venture too far to find a new world, because just over 4 light-years away from us is Proxima Centauri b. That's right, the closest exoplanet that might one day become humanity's potential second home. You might be thinking, 4 light-years, that's pretty far, but let's put it in perspective. If we were to travel to Proxima Centauri by using current technology, it would take us about 70,000 years. That's a seriously long road trip, but on the cosmic scale, it's actually relatively close. Proxima Centauri b orbits around Proxima Centauri, a red dwarf star that's located in the Alpha Centauri star system, the closest star system to our own Sun. While our Sun is a yellow dwarf star, red dwarfs like Proxima Centauri are much smaller and cooler, but they also burn their fuel for far longer. That means Proxima Centauri could keep its planet stable for billions of years, which is exactly what we want for a habitable planet. The proximity of Proxima Centauri b to Earth makes it a fascinating candidate for exploration, and thanks to our growing technological advancements, who knows, maybe one day we'll set foot on this distant world. The thing that makes Proxima Centauri b even more intriguing is that it's within reach compared to other exoplanets, which are often hundreds or even thousands of light-years away. So, while we can't pack our bags and go just yet, this planet offers a real hope for future generations to travel, study, and perhaps even live beyond our own home planet. Isn't that exciting? Location in the habitable zone. The most exciting part of Proxima Centauri b, its location in the habitable zone. You've probably heard this term before. It's often called the Goldilocks zone, and it's where conditions are just right for liquid water to exist on a planet's surface. Not too hot, not too cold. It's the perfect sweet spot for life to thrive. And guess what? Proxima Centauri b sits smack dab in the middle of this habitable zone. Being in the habitable zone is a game changer. It means that just like Earth, Proxima Centauri b could have liquid water on its surface, which is one of the key ingredients for life as we know it. Think about it. Water is essential for all known life forms, from the tiniest microbe to the largest mammals. So the fact that this planet is positioned at just the right distance from its star means it has the potential to harbor conditions that could support life. This is one of the primary reasons scientists are so eager to study Proxima Centauri b. It might not just be a planet, it could be the next big discovery in our search for extraterrestrial life. But it's not just about being in the habitable zone, it's about how Proxima Centauri b's orbit interacts with its star. Unlike Earth, which is in a stable orbit around the Sun, Proxima Centauri b's orbit is likely to be influenced by the intense stellar radiation from its red dwarf star. That's a challenge. And we'll talk more about how that affects its potential for habitability in the next sections. But for now, it's enough to say that being in the habitable zone gives Proxima Centauri b a huge advantage in the search for life beyond Earth. Could it be the place where life is waiting to be discovered? Only time will tell. Earth-like size and composition. So what makes Proxima Centauri b so fascinating? Its size and composition. Unlike the gas giants like Jupiter or Saturn, Proxima Centauri b is a rocky planet, much like Earth. It's about 1.3 times the mass of our home planet, which means it's large enough to have a solid surface but not so big that it would be a gas giant. This is a huge advantage because it means that, theoretically, Proxima Centauri b could have an atmosphere, oceans, and even land masses just like Earth does. Imagine a world that could resemble our own in some ways. It's like having a twin out there in the vast expanse of space. The fact that Proxima Centauri b is a rocky planet opens up so many possibilities. It could have similar geological features like mountains, valleys, and maybe even volcanoes. Its surface might be shaped by tectonic activity, just like on Earth, where the plates beneath our feet shift and create the continents and oceans. And speaking of oceans, Proxima Centauri b's Earth-like size means it could potentially have water in liquid form, which is crucial for life. The idea that a planet in our cosmic neighborhood could have a solid surface and liquid water makes Proxima Centauri b incredibly intriguing to scientists. They're excited to study the composition of the planet's surface, its possible atmosphere, and whether it could support life forms similar to what we have here. If Proxima Centauri b is truly Earth-like, it could also offer a glimpse into the types of conditions that make a planet habitable. The more we learn about it, the better we can understand what's needed for life to thrive on other worlds. The fact that this planet is rocky and roughly the size of Earth only adds to its allure as a potential new home for humanity, or at least a place to search for extraterrestrial life. Potential for liquid water. Let's dive into one of the most exciting aspects of Proxima Centauri b, the potential for liquid water. Water is the key ingredient for life as we know it. And for years, scientists have been on the lookout for planets that might have water in its liquid form on their surface. Proxima Centauri b, situated in the habitable zone of its star, could be one of those rare gems where liquid water could exist. Being in the habitable zone means that Proxima Centauri b is at the right distance from its star, not too close so that water would evaporate, and not too far so that it would freeze. This perfect distance could allow the planet to have water in liquid form on its surface, which is essential for life. Picture vast oceans, rivers and lakes, just like here on Earth. And water doesn't just provide a home for life, it's also a key ingredient for maintaining an environment that could support complex ecosystems. It could even be the thing that makes this planet more Earth-like than we ever imagined. But there's more to this. The possibility of liquid water on Proxima Centauri b also depends on the planet's atmosphere, which we don't fully understand yet. If the planet has a thick atmosphere, it could create the right conditions for water to remain liquid on its surface, even if Proxima Centauri emits strong radiation. Without an atmosphere, the water would quickly evaporate or freeze, making the planet less likely to support life. That's why studying Proxima Centauri b's atmosphere is one of the biggest focuses for scientists. If they can determine that the planet has the right conditions, they'll be one step closer to answering the age-old question, are we alone in the universe? Tidally locked rotation. Let's take a moment to talk about something that makes Proxima Centauri b quite unique, its rotation. Unlike Earth, where day and night give us a rhythmic balance, Proxima Centauri b is likely tidally locked to its star. This means that one side of the planet is always facing the star, while the other side is in eternal darkness. It's a fascinating phenomenon that happens when a planet's orbit around its star syncs up with its rotation in such a way that it always shows the same face to the star. This tidally locked rotation can create some extreme conditions on Proxima Centauri b. On the side that faces its star, temperatures could soar to unimaginable heights, while the dark side would likely be freezing cold. These vast temperature differences would create unique weather patterns, possibly even powerful winds or atmospheric currents that move from the hot side to the cold side in an attempt to balance out the heat. The intense heat on the day side and the icy cold on the night side might make life as we know it challenging, but it also opens up possibilities for life forms to adapt to such extremes. Maybe life on this planet doesn't thrive in the traditional sense, but in some way we can't yet imagine it finds a way to exist. Now, if Proxima Centauri b does indeed have an atmosphere, it could mitigate some of these extreme temperatures, circulating heat between the two sides and perhaps creating a more habitable environment. That said, the tidal locking of the planet could make the atmosphere's stability a major factor in determining whether life could survive here. It's a delicate balance, but one that might lead to the discovery of life forms unlike anything we've ever encountered before. Stellar activity and radiation. There's no denying that Proxima Centauri b is a fascinating exoplanet, but being so close to its star as a red dwarf brings some serious challenges for its habitability. Red dwarfs like Proxima Centauri are known for their stellar activity, which includes strong solar flares and radiation bursts that can be harsh on nearby planets. So, while Proxima Centauri b is in the habitable zone, the question arises, could it withstand the intense radiation from its star? Let's dive into that. Proxima Centauri, unlike our Sun, is much smaller and cooler, but it's also far more active. It regularly emits powerful flares and radiation, which could strip away the atmosphere of a planet in the habitable zone. This radiation could bombard the surface of Proxima Centauri b, making it harder for life to exist, especially if it lacks a strong magnetic field or protective atmosphere. Imagine being in a constant battle against radiation that could fry the surface and potentially evaporate any water that might exist. It's not an easy environment to thrive in. But here's the twist, Proxima Centauri b could still have a fighting chance. If it has a thick atmosphere, much like Earth's, it could protect the surface from harmful radiation. Additionally, some scientists believe that certain life forms could adapt to these conditions, developing protective mechanisms to survive in environments with high radiation levels. After all, life on Earth has found ways to thrive in extreme conditions, from deep-sea vents to radioactive zones. The ability of Proxima Centauri b's atmosphere to withstand its star's harsh radiation will be crucial in determining whether this planet can support life, or if we're looking at a world where only the toughest organisms could survive. Scientific interest and exploration. Proxima Centauri b has certainly captured the imagination of scientists, astronomers, and space enthusiasts alike, but what's next? What are the next steps for exploring this fascinating exoplanet and uncovering its secrets? The truth is, Proxima Centauri b is a top contender in the search for habitable planets and extraterrestrial life. It's a planet that could offer us insights into the possibilities of life beyond Earth, and with the right tools and technology, it might not be as far out of reach as we once thought. So, how do we study a planet that's over 4 light-years away? With the development of advanced telescopes and new technologies, astronomers are able to gather more information about Proxima Centauri b than ever before. One of the most exciting prospects on the horizon is the use of next-generation telescopes, such as the James Webb Space Telescope, which is designed to peer deeper into space and study the atmospheres of distant planets in incredible detail. This could help scientists determine if Proxima Centauri b has an atmosphere, how thick it is, and whether it contains the necessary elements to support life. In addition to the tools we have today, future space missions could take us even closer to understanding Proxima Centauri b. There are discussions within the scientific community about sending probes to explore this distant exoplanet, though it's a massive undertaking that would take decades to accomplish with current propulsion technology. One potential mission could involve the Breakthrough Starshot Initiative, a project aimed at sending small, light-powered probes to nearby stars at a fraction of the speed we're capable of now. These probes could send back data on the planet's surface and atmosphere, dramatically enhancing our understanding of its potential habitability. While we're still in the early stages of exploration, Proxima Centauri b holds the promise of answering some of humanity's biggest questions. Is there life beyond Earth? What does a potentially habitable planet look like up close? By continuing to study this distant world, we not only expand our knowledge of the universe, but also bring ourselves one step closer to understanding our place within it. This pursuit might be the key to discovering a new world for future generations. Thanks for joining me on this journey to explore Proxima Centauri b, one of the most exciting potential habitable worlds beyond our solar system. While we still have many questions about its true nature, and whether it can support life, every discovery brings us closer to understanding our place in the cosmos. The universe is vast and full of mysteries just waiting to be uncovered. Stay curious, keep looking up, and remember, space holds endless wonders for those who seek them. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. In 1924, we thought the Milky Way was the entire universe, until Edwin Hubble proved us wrong. What looked like a faint blur in the night sky was actually the Andromeda Galaxy, bigger than our own and filled with over 1 trillion stars. That discovery shattered our place in the cosmos. And here's what most don't realize. Andromeda is coming. Slowly, silently, it's moving toward us, set to collide with our galaxy in a few billion years. So, how does it feel knowing the universe isn't just vast? It's in motion, and we're part of something far more epic than we imagined. Meet our galactic neighbor. There's a silent wanderer hanging in our night sky, so vast, so close, yet so quietly overlooked. You might have seen it without realizing, a faint smudge in the dark, barely noticeable to the naked eye. But that humble smudge, it's the Andromeda Galaxy, the closest spiral galaxy to our own Milky Way. And it's not just a neighbor, it's a giant, bigger and more massive than our own galaxy. If you could travel at the speed of light, it would still take you over 2.5 million years to get there. That's not just distance, it's a time capsule. The light we see from Andromeda tonight actually left it during the time early humans were first learning to use tools. It's like looking through a cosmic window into the deep past. But Andromeda isn't just a relic, it's a message. A reminder that even in the vastness of the cosmos, we're not alone in the dark. Galaxies like ours aren't solitary islands floating aimlessly. We're part of a larger galactic family. And Andromeda? It's our sibling, slowly drifting closer every second. Isn't it wild that while we scroll through phones and binge-watch shows, entire galaxies are inching toward one another for a cosmic reunion? Size, distance, and visibility. Let's break down just how massive our neighbor really is. Andromeda spans about 220,000 light-years across. That's nearly double the size of the Milky Way. And within that spiraling colossus are over 1 trillion stars. Yes, trillion. With untold numbers of planets orbiting around them. Some astronomers even suggest it might contain twice the stars we have. And here's the incredible part. On a clear night, far away from city lights, you can actually see Andromeda with your own eyes. No telescope, no binoculars, just you in the night sky. What you're seeing, though faint, is the furthest object visible to the naked human eye. That fact alone makes it special, because without any tech or training, you're literally staring across time and space. Think about that. You're standing on a tiny planet, looking out across 2.5 million light-years. The light hitting your retina tonight left Andromeda when early ancestors of modern humans were first learning to stand upright. You're not just stargazing, you're time-traveling. It's not just a galaxy, it's a reminder that the universe is much, much bigger than our day-to-day worries. Structure and composition. You might think galaxies all look the same, a bunch of stars swirling in space, but Andromeda? It's got some serious style. This majestic spiral galaxy has a glowing central bulge, 2 massive arms that twist outward, and hundreds of smaller star clusters sprinkled throughout like cosmic confetti. Scientists estimate it has over 1 trillion stars, compared to the Milky Way's 200 to 400 billion. That's 5 times more stars lighting up its structure. It even has satellite galaxies of its own, just like we have the Magellanic Clouds. Andromeda's arms aren't just starry decoration. They contain countless planetary systems, star-forming nebulae, and possibly even black holes hiding deep inside. What's fascinating is that it isn't chaotic, it's organized beauty on a scale we can barely comprehend. Even the dust lanes, those darker regions cutting across the spiral arms, are essential. They're not voids, but rich with gas that could one day form new stars. It's like Andromeda is a living, breathing structure constantly creating, evolving, changing. From its bright, dense core to the wispy edges of its arms, every part of it tells a story billions of years old. History of discovery. Long before we knew what a galaxy even was, Andromeda had already made an impression. Ancient Persian astronomers wrote about a little cloud in the sky, one that didn't twinkle like the stars. That cloud was Andromeda, and for centuries that's all anyone thought it was, a fuzzy patch in our own galaxy. Then came 1924. Edwin Hubble, yes, the guy the telescope's named after, changed everything. Using a powerful telescope, he found variable stars inside Andromeda and measured their distance. What he discovered shocked the world. Andromeda wasn't inside the Milky Way at all. It was its own separate galaxy, millions of light years away. This moment shattered our idea of the universe. Suddenly, the Milky Way wasn't the universe, it was just one galaxy in a cosmos full of them. Andromeda opened the floodgates to modern astronomy. It was the first galaxy we truly understood as being independent of our own, and it forever expanded our cosmic horizon. That fuzzy smudge? It forced us to rewrite everything we thought we knew, and in doing so, it made the universe feel both infinitely bigger and far more connected. Collision course with the Milky Way. Every second Andromeda is moving closer to us, about 68 miles per second. That means with every heartbeat, the distance between our galaxies shrinks just a little more. It's not a maybe, it's a cosmic certainty. Scientists predict that in about 4 billion years Andromeda and the Milky Way will collide. Not like a violent explosion though. Because space is so vast and stars are so far apart, most will simply drift past one another, dancing through gravity's pull. It's more of a slow-motion ballet than a demolition derby. Over time, this celestial interaction will stretch, twist, and eventually merge both galaxies into a brand new formation, Milkomeda or Milkdromeda, as some astronomers playfully call it. Earth might survive, the sun might still shine, but the night sky will change forever. If future humans or civilizations exist then, they'll look up and see skies ablaze with stars from both galaxies. It's wild to think that something as stable and constant as our galaxy is part of a much bigger story, one that's still unfolding. Our peaceful skies today? They're the calm before a magnificent billion-year storm. Possibility of life. What if we're not alone, even just one galaxy over? With over 1 trillion stars and potentially billions of planets, Andromeda might hold secrets we can't yet fathom. Some of those planets could sit in the habitable zone, the sweet spot where liquid water can exist. That's the first ingredient for life as we know it. And since Andromeda is older than the Milky Way, some of its stars have had a head start by billions of years. What if intelligent life evolved there long before humans ever lit their first fire? Or what if ancient civilizations rose and fell before we ever looked up? While we haven't found signs of life in Andromeda, we're only beginning to understand its vastness. Most of its planets are too far for us to study in detail, yet. But advancements in telescopes and interstellar tech could one day let us glimpse alien skies, distant oceans, or even civilizations waving back. Right now, it's all questions and wonder, but maybe that's the point. The search for life in Andromeda isn't just about science, it's about connection, about asking, are we really the only ones out here? The hidden skeleton of Andromeda. You can't see it, you can't touch it, but it holds everything together. Nearly 90% of Andromeda's mass is invisible, made of something scientists call dark matter. It doesn't emit light, it doesn't reflect it, and yet, it's everywhere, acting like a hidden skeleton that binds galaxies. We only know it exists because of what it does. Andromeda's stars rotate at speeds that shouldn't be possible if only visible matter existed. By all logic, those outer stars should have flung off into deep space by now, but they haven't. Something is keeping them tethered, and that something is dark matter. It's like a silent architect, shaping galaxies from the shadows. And here's what's even more fascinating. Andromeda's dark matter halo stretches far beyond its glowing arms, like an invisible shield. It might even be interacting with the Milky Way's own dark matter cloud as we speak. The more we study Andromeda, the more we realize it's not just about stars and light, it's about the unseen forces that define the universe. Think about that. Most of what exists in our closest neighbor is something we still don't understand. A cosmic transformation. As we continue to observe Andromeda, one question persists. What will happen to both galaxies once they collide? While this event is billions of years away, the concept of such a cosmic transformation is deeply intriguing. Astronomers believe that the merging of the Milky Way and Andromeda will not result in a catastrophic collision of stars. After all, space is vast, and stars are spaced far apart. Instead, it will be a slow dance of gravitational forces, causing the two galaxies to slowly stretch, twist, and eventually fuse together into a brand new galaxy. Some suggest that this new galaxy could be called Milkomeda or Milkdromeda. However, as the galaxies collide, their supermassive black holes will likely converge as well, sparking a new and intense period of star formation in the aftermath. With this collision, new stellar structures will form, possibly creating an even more magnificent cosmic display in the future sky. For life on Earth, this event may not pose any immediate threat, as the collision will unfold over millions of years. But what about future civilizations? Will they witness the collision in real time, perhaps from a planet in the new galaxy? The possibilities are endless, and the collision between Andromeda and the Milky Way is sure to redefine the very nature of the universe as we know it. It's a reminder that even the most stable elements in the cosmos are subject to change, and the future of the universe is written in the stars. And there you have it, the Andromeda Galaxy, a giant in our cosmic neighborhood with mysteries that continue to fascinate astronomers. Isn't it amazing to think about the vastness of the universe right next door? If you're as amazed by the wonders of space as we are, make sure to keep exploring with us. And if you love discovering the secrets of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures with space facts. Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worshipped them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight, and it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon, and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our Sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation. which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. In 1610, Galileo saw Saturn, but he didn't understand it. His telescope showed strange ears, not knowing they were icy rings that would puzzle humanity for centuries. Today we know those rings are vast, delicate, and possibly vanishing before our eyes, a cosmic masterpiece, fading in silence. Scientists think a lost moon or a celestial collision may have created them. But we still ask, why Saturn? Why not the others? If you stood beneath those radiant bands, would you feel awe or sorrow for what's slipping away? Let's explore the truth behind Saturn's vanishing crown. The enigmatic beauty of Saturn's rings. If you were standing on the surface of one of Saturn's moons, you'd see something that almost doesn't look real. Towering arcs of shimmering ice stretching across the sky like a celestial ribbon. For centuries, this sight has mystified stargazers and astronomers alike. Saturn's rings aren't just decoration, they're clues. Clues to a violent cosmic past, to the invisible forces that shape our universe, and to the kind of beauty that only space can sculpt. But what's wild is that when Galileo Galilei first saw them in 1610, he had no idea what he was looking at. His telescope was primitive, and to him, Saturn looked like it had ears. It wasn't until decades later that scientists realized these weren't ears or wings, but rings. Massive, flat rings made of something far more fragile than rock, ice. Not one single ring, but thousands of tightly packed ringlets spanning hundreds of thousands of kilometers. They're wide enough to stretch nearly the distance from Earth to the moon, but they're razor thin, barely 10 to 30 meters thick in most places. So, why do they exist at all? Why Saturn and not Jupiter or Uranus in the same way? That's where things get fascinating. Let's break it down. What Saturn's rings are really made of. Most people think Saturn's rings are solid, like a giant hula hoop floating in space, but that couldn't be further from the truth. These rings are made of billions, yes, billions of tiny particles, each orbiting Saturn independently. They range from microscopic dust grains to house-sized boulders, and they're mostly composed of water ice, which explains why they reflect sunlight so brilliantly. But here's the twist: they aren't pure ice. Hidden among the icy debris are specks of rocky material and organic compounds. That's right, some of the same carbon-rich molecules that may have played a role in forming life on Earth are found in Saturn's rings. Scientists think the difference in ring color, some being brighter, others darker, might be due to the varying amounts of this dusty contamination. And while they look smooth from afar, the rings are more like a cosmic traffic jam up close. These particles constantly collide, clump together, and break apart again. It's chaos, but organized chaos ruled by gravity. Every motion, every gap between rings is shaped by Saturn's moons tugging on the particles like invisible hands sculpting art. And that chaos may hold the key to how the rings even got there in the first place. How did Saturn's rings actually form? A moon torn apart. That's one of the most widely accepted theories behind the formation of Saturn's rings. Sounds brutal, right? And it was. Scientists believe that long ago, Saturn may have had a large icy moon that drifted too close, within the planet's Roche limit, a point where Saturn's tidal forces became stronger than the moon's own gravity. The result? The moon was literally shredded into pieces. But that's just one version of the story. Another theory is even more chaotic. What if two moons collided at high speed, turning into a spray of debris that spread around Saturn like a slow-motion explosion in space? Over time, gravity helped those icy fragments settle into the thin structured rings we see today. This theory is supported by how flat and disc-like the rings are, just like the aftermath of a spinning cosmic smash-up. Some scientists even think these rings could be the remnants of material that never formed into a moon at all, a frozen ghost moon that failed to become whole billions of years ago. But here's the catch. No matter the theory, one thing remains clear: the rings are a result of destruction. Something had to break, rip, or explode for them to exist. Saturn's beauty is born out of cosmic violence, and that makes it even more incredible. Are Saturn's rings old or surprisingly young? You might assume Saturn's rings have been around forever. After all, the planet itself is over 4.5 billion years old. But what if I told you that the rings might be younger than the dinosaurs? That's right. Some scientists now believe that Saturn's rings may have formed as recently as 100 million years ago, when T-Rex roamed Earth. That's practically yesterday on a cosmic timeline. How could something so massive be so young? It all comes down to their brightness. The rings are incredibly reflective, meaning they haven't been exposed to space dust and debris long enough to darken over billions of years. On the flip side, there's a competing theory that says we've just gotten lucky. Maybe the rings really are ancient, but their icy particles constantly recycle themselves, colliding, breaking down and reforming, keeping them looking fresh and clean despite their age. Cassini's mission tried to settle the debate, measuring how much ring material is falling into Saturn's atmosphere. The data leaned toward a shorter lifespan, meaning we may be living in a rare moment in time when Saturn is dressed in her finest. Either way, the rings are temporary. Whether they're ancient or newborn, they won't last forever. We're witnessing a fleeting masterpiece, and most of the universe won't even get the chance. What NASA's Cassini mission uncovered about the rings. One spacecraft got closer to Saturn's rings than anything in human history, and it changed everything. NASA's Cassini mission, launched in 1997, didn't just orbit Saturn, it danced through its rings, it flew between them, and what it saw was astonishing. Cassini revealed that the rings aren't uniform at all. They're full of waves, literal ripples caused by gravitational tugs from Saturn's dozens of moons. These waves aren't just beautiful, they act like seismic maps. They help scientists understand Saturn's interior structure, the same way earthquakes help us understand Earth's core. Wild, right? And then there were the propellers, tiny gaps carved by moonlets no bigger than a city block. These baby moons move like little shepherds, pulling and pushing ring particles, leaving trails behind like ships through ice. It's a whole ecosystem of motion. Collisions, orbits, spirals, all governed by gravitational forces we can't see but Cassini could feel. What stunned scientists most was the sheer level of detail. They found sharp edges, sudden gaps, and braided structures like strands of hair woven by the cosmos itself. Saturn's rings aren't just pretty, they're alive with motion. Cassini didn't just observe them, it revealed a complex, dynamic system still evolving before our eyes. Will Saturn's rings eventually disappear? They look eternal, but Saturn's rings are fading. Right now, as you read this, those magnificent ice particles are falling, bit by bit, into the planet they orbit. It's called ring rain, and it's caused by Saturn's magnetic field, pulling charged particles from the rings down into its atmosphere. NASA estimates that each second, tons of ring material is being lost forever. Think about that, a structure hundreds of thousands of kilometers wide, vanishing grain by grain like sand in an hourglass. Scientists now believe the rings could be gone in as little as 100 to 300 million years. In cosmic time, that's a blink. And that means we are alive at one of the rare moments in history when Saturn even has rings this bright and massive. Most other planets don't get this kind of spotlight, we just happen to be born at the perfect time to see it. The rings are like fireworks on a galactic scale, stunning, fleeting, and impossible to ignore. One day future civilizations may only see Saturn as a plain gas giant. No icy crown, no shimmering halo, just a memory left in textbooks and telescopes. And that makes every glance at Saturn now feel a little more sacred. The role of Saturn's moons in shaping the rings. Saturn's moons play an incredibly crucial role in the creation, maintenance, and structure of its rings. These moons act as both sculptors and guardians of the rings, exerting gravitational forces that shape the particles within them. Saturn has over 80 moons, but many of them are especially important for the delicate dance of the planet's rings. Some moons, like Pan and Atlas, are small yet vital to the structure of Saturn's rings. They create gaps, or propellers, within the ring material, where the gravitational pull of the moon pushes particles into a tightly packed structure while leaving a gap in its wake. These gaps resemble the paths left behind by ships moving through ice, and they help maintain the ring's shape and distribution. The effect is not just visual, but also vital for the dynamic behavior of the ring system. On the other hand, moons like Mimas, Enceladus, and Dione have more indirect roles. They interact with the rings by generating gravitational waves, small fluctuations that ripple through the material, organizing it into neat, concentric bands. These waves influence the ring particles' movement and maintain their organized chaos. Through their gravitational interactions, Saturn's moons help to prevent the particles from scattering away into space, ensuring the rings stay intact over millions of years. Interestingly, the material in Saturn's rings is not static, it's in constant motion, constantly being tugged by the moons. This interaction is a prime example of how moons and rings coexist in a delicate balance, with each influencing the other. Without these moons, the rings would likely lack the fine structure and order they currently display. Rather than a simple floating collection of ice, Saturn's rings are a complex, gravitationally controlled system that relies heavily on the nearby moons to sustain its beauty and form. Thanks for joining me on this incredible journey through Saturn's mysterious rings. From icy debris to shattered moons, the secrets they hold are as vast as space itself. There's still so much we don't know, and that's what makes it thrilling. Every new discovery brings us one step closer to understanding the universe we call home. So, what do you think created Saturn's rings? Drop your thoughts in the comments below. Let's start a cosmic conversation. And if you love discovering the secret of the universe, don't forget to subscribe to Space Facts and hit the bell icon for more adventures.